So this question we're dealing with is the question number 36. It's a case study. Let's read the case study and try to understand what is the case study. So Amit's father wants to construct a tank with a rectangular base and sides open at the top with depth 3 meters and volume of 75 cubic meters. If building of the tank costs rupees 100 square meter for the base and rupees 50 per square meter for the sides, then find the cost of least expensive tank and find the dimensions of the tank. Okay, so once you see this question, the first thing is what strikes you is not the construction, but the word least expensive, right? The least expensive part is is what strikes me to start with. Okay, so I'm just marking it so that you can also see, right? I have seen the word least expensive. Okay, okay, let's see. So he wants to build a tank. It's a rectangular base and sides. Okay, so which means it's a cuboid which is being built, right? So it's more of a cuboid. Let's build a cuboid. So maybe this is a kind of tank he wants to build, and the depth is given to be the depth of the tank is given to be 3 meters. The overall volume of the tank is 75 cubic meter. Okay, so we need a volume. Okay, now you need material to build the tank, right? So you will need a sheet of aluminium maybe, and it says that the tank costs rupees 100 for the base. So base is expensive, right? Maybe this is made up of some good material. So base cost on per square meter basis is 100 rupees per square meter. Okay, which is area, right? So you buy the sheet in meter squares, and the sides, right? The sides are cheaper. So maybe inferior quality material. So this is 50 rupees per square meter. Fair enough. Okay. Now, see, we have to build the volume is fixed. This is the volume we need. We are going to go to the market and we need to decide how much is the cost of building this tank, and the cost is coming from the material. So for a fixed volume, how much material do we need, which means how much area we will need, right? So the area of the surface area of the tank, which is the amount of sheet you need to build this. So let's say the length of this tank is X and the breadth of the tank is Y, because the height is fixed, right? But let's talk about the surface. If you see the bottommost part of the circuit, okay, and you can see the tank is open from the top, right? So open at the top. So at the bottom, what I will do is I will have a sheet which is X into Y. And if I look into the sheets which are the standing sheets, one is this and the one behind this, the area is going to be 3 into X, and two sheets are there into 2. Where did I get 3 from? I got 3 from the concept of height, right? So height into the overall length. Okay, now so I have done this, the back one, and I have to worry about this sheet, right? So this sheet actually is plus what is the, I have taken this as Y as the width, and this thing is known to me, it is 3. So this is a total sheet which you need to build this tank. We have to use least amount of this sheet, and that's the only way we will be able to economize, right? So if you want to talk about the overall cost we have incurred, okay, so this is the bottom, right? This is the bottom, the most expensive. X into Y. This is the bottom, which is most expensive. And for 1 meter square, it costs you 100. So 100 X into Y is the cost of the bottom. And if you look into this, This is 2 times, so this will also be 2 times because you have this side and this side, right? So I can reduce the size also or show it to you. Okay, so let's see. Let we took this as y into 3. This is 3, this is y, and there are two sides, so into 2, right? So 100 rupees per square meter is the rate of the bottom, and let's talk about now the other two sides. So other two sides are billed at 50 rupees. So this is 50 rupees and 6x plus 6y. I just solved this as 6x and this is 6y. So this is the overall cost of building the tank. But the question is how to minimize it. What length and what x and y should be there. So because I want to buy the least amount of the material. That is my endeavor here, right? If I want to buy the least amount of material, then the and I know the volume of a cuboid is how much, right? 3 is the height which is given into x into y. So this is fixed. 75 is equal to 3xy and xy is equal to 25. So let's say the cost is now coming out to be 100xy plus 300x plus 300y. So if I put y is equal to 25 by x from my volume and I substitute it here, I will get cost is equal to 100 into x into 25 by x plus 300x plus 300 into 25 by x. Because if I were to do minimization, which is maxima and minima of this, I told you least expensive was very stocky standing, right? So the cost is coming out to be okay. This gets cancelled, so this becomes 2500 plus 300x plus 7500 by x. Let's do a derivative of the cost with respect to x. So this is 0, this is 300, this is 7500 by 2x square. Okay, now 300 is equal to 75 by 2x square. This is 300 and this is 25. So x square is equal to x square, right? Will be 25 upon 2 into 3. So x is equal to plus minus 5 upon under root 6 meters. Now x cannot be negative, it's a real thing like a cuboid. So how can you have a breadth and length to be negative? So x is equal to 5 by root 6, we know this also. So y is equal to 25 by 5 into root 6 is equal to 5 root 6. Okay. If I take a double derivative also of this equation, so d square c by dx square is equal to minus 7500. This will become plus, okay, and into 2 divided by x cube divided by 2, right? This 2. So this gets cancelled, and if you put a value of x to be a positive, right? So double derivative will be positive, which means this x corresponds to least cost. Okay. So we know that for this dimension, if we keep the dimension as this and this, the value of the cost is going to be the least. Let's find this cost now. What we will do is we will substitute the values of x and y here and we will calculate the cost. Part 1 is solved. Why this cost is the lowest cost? Because we used that what should be the value of x, okay, for which the cost is lowest, using the principle of maxima and minima. So whenever you see the words least, highest, maxima, minima, greatest, such questions are generally put as the maxima minima questions. Generally what happens is you have two variables. You have to eliminate one of them from the given information. In this case, volume was known to us. So the given information was used and we were able to establish one equation. The second equation came from what is to be minimized, right? We have to minimize the cost of building the. So second equation was the cost, and making the cost is a very nine standard or 10 standard level thing. That this is the surface area per meter square basis what is the cost per meter square cost multiplied by the area gives me the overall cost of building it. So this is the overall cost of building it, but we do not for what value of an x and y the cost will be minimum, and that is where the maxima and minima comes to our rescue. So we have to use maxima and minima in physics also, in maths also, and one should be able to see the words, the key words being used. So if you put a logic in this, what generally is happening in these questions is there is a given condition. Okay, so there is a given condition. First, create an equation for the given condition, and this volume was given, the height was given. It's an open tank, so the top surface is also open, and no sheet will be used, no expenditure. The second was what is to be minimized, cost. Second equation, right? Generally what will happen is the cost equation or the thing which has to be minimized or maximized will be in two variables, okay, like x and y. Now we need one variable only in maxima minima. Cost is to be minimized. We need the complete equation in either x or y. So what do we do? We use the given information. Volume is equal to LBH. So we were able to establish that the overall volume, which is 3xy, is equal to 75. And then we used relationship between x and y and substituted in the cost. And then we took the derivative of dc by dx. We could have also done dc by dy, provided we would have eliminated x here, right? We could have written x is equal to 25 by y. So all equation would have become. So this is the way you need to approach. There is a given condition in the question. You don't need to be scared of any maxima minima question. You just need to think about a given condition. Equation number one, that given condition will link the variables. X and y are unknown. It has linked. Use this given condition in what needs to be maximized and minimized. This maximized and minimized quantity will also give you equation in two variables, but you need one variable. So whatever is a given condition, get one variable from there and substitute here. Make the equation to be one variable and then start doing single derivative, double derivative testing and find the value of the variable, which amounts to a maxima situation or minima situation depending on your double derivative test. So I hope you understood how to handle a maxima minima question. All you need to do is practice 2-3 questions in which material is involved, volume is involved, surface area is involved, a triangle is involved. 4-5 questions done with logic will ensure that you're able to do almost all the questions. So thank you very much and look forward to meet you.